Good morning, students. Okay, and continuation in chapter number 7, integral. Now, today we are going to start the new topic, the definite integral, exercise 7.9. Now, actually, exercise 7 point after 7.6, 7.7, and 7.8 deleted for this year, okay, by CBSE, and so that we are going to start the definite integral portion, exercise 7.9. So now see the basic fundamental formula here. Let's see the function fx dx from lower limit a to b. It will be here fb minus fa. Fb minus fa. Okay. So this will be applicable function here, basic fundamental function. Okay. Now, I am taking some question from exercise. Very first question, limit minus 1 to 1 x plus 1 dx. Okay, just you see here, apply the simple integral, whatever we are already doing in integral portion. Okay, so x become x square by 2 and 1 become x, and it is minus 1 to 1, lower limit to upper limit, lower limit to upper limit. Here we will apply the upper limit minus lower limit application here, 1 square by 2 plus 1 minus 1 square by 2 plus minus 1. Simplifying it, 1 upon 2 plus 1. Again 1 upon 2 minus 1, 1 upon 2 plus 1 minus 1 upon 2 plus 1, finally answer is 2. So you can see here that is a very simple way to solve. Now I take one another question. Two to 3 1 upon x, lower limit is 2, upper limit x, dx. Again, as I told you, that is apply the basic fundamental, okay, 1 upon 3. So, application of 1 upon x is log x, 2 to 3, 2 to 3. So, it is log 3 minus log 2. And finally, we can write log 3 by 2. And in definite integral, when limit is applicable, so there is a no integration constant c here. One another question, trigonometrical part. Zero to pi by 4 sin 2x dx. Sin 2x dx. Okay. Simply again the basic, apply the basic fundamental formula of sin 2x, which is cos 2x by 2, which is cos 2x by 2, and it will be negative minus cos 2x by 2, 0 to pi by 4. Okay, the integration of sin 2x is minus cos 2x, and the successive differentiation, which is 2, apply minus 1 upon 2 side, cos 2x 0 to pi by 4, and 1 upon 2 cos 2 into pi by 4 minus cos 0. This is cos pi by 2, and cos 0 is cos 0. And cos 90 degrees value is 0, and cos 0 is 1. Finally, answer is 1 upon. Given another question of substitution, integration dx 1 minus x square. Okay, integration of dx 1 minus x square, and limit is 0 to 1, lower limit 0, upper limit square. Now we know that the integration of 1 minus x square is sine inverse x, which is inverse case 0 to 1. So sine inverse 1 minus sine inverse 0. Sine inverse 1, that is the value of sine inverse 1, which is 5 by 2, and this is 0, answer is 5 by 2. Okay, this is your final answer. I again told you there will be no integration constant because this is definite integral is fixed, so there will be no any constant applicable in here. Okay, the next question I am taking to 3 1 upon x square plus 1 dx. Okay, and x is here, x. So this we will do by substitution method. Let x square plus 1 is equal to t. X square plus 1 is equal to t. So it will be 2x dx is equal to dt, means x dx is equal to dt by 2. So now there will be conversion here. X dx will become dt by 2, and 1 plus x square, this is t. And also when we are changing x to a new function t, so limit will also change, because this limit, basic limit 2 to 3 based on the function t, Okay, so now applying x equal to 2 here for limit. Here for limit t is equal to 2 square plus 1 means 5. For lower limit and upper limit, for our upper limit, now applying 3 here, 3 square plus 1, 10. So limit would be 5 to 10. So find next stage, 1 upon 2, 5 to 10, 1 upon t dt, its value is 1 upon 2 log t 0, 5 to 10, 5 to 10. Just see here, 1 upon 2 log 10 minus log 5. Okay, log 10 minus log 5. So 1 upon 2 log. This is your final answer. Now I am taking some another question. From exercise 7.10. Exercise 7.10, some substitution case. Zero to 1 x square plus 1 Now let x square plus 1 is equal to t, as we have done in previous question exercise. X square plus 1t. So 2x dx is equal to dt become x dx is equal to dt by 2. So changes are here, dt by 2, and this is t, and now limit will change. For limit when x equal to 0, then t is equal to 1, and x equal to 1, t is equal to 2. So limit would be 1 to 2. It means 1 upon 2 log t 1 to 2, and then log 2 and log 1. This is your final answer. So this is case of substitution. Okay. One very interesting question from trigonometry substitution case. Question number 2. Integration 0 to pi by 2 sin phi square root cos to power 5 phi d phi. Okay. Here we will suppose let sin phi is equal to t. Sin phi is equal to t. So you can see here, first this is sin phi, we change here, and divide this cos to power 5 phi into 2 part, cos to power 4 phi into cos phi d phi. Now changes is there, sin phi is equal to t, so cos phi d phi is equal to dt. Okay. In next stage, limit 0 to pi by 2 sin phi, and this cos to power 4 phi, you can write it cos square phi cos square phi, means 1 minus sin square phi whole square and cos phi d phi. Now put the changes here, sin phi is t root t and 1 minus t square, and this is the dt. And what about limit? Same thing we will change, that sin 0, okay, for limit when phi is equal to 0, so t will be sin 0. Just see here, put phi is equal to 0, sin 0 is 0, means t is equal to 0. When phi is equal to pi by 2, so t is equal to sin 90, sin 90 is 1, the limit will be 0 to 1. So accordingly we can change the limit also. Okay, first we will take the substitution, and whatever the basic function of substitution we have taken here, okay, we will change accordingly. And now 0 to 1, t to power 1 upon 2, apply the formula here, a square b square minus 2ab, 8t to power 4 minus 2t square, okay, and plus 1. The more changes, t to power 9 by 2, okay, 4 and a half, minus t to power 5 by 2 plus t to power 1 by 2 dt. Okay, now accordingly we will apply the integration here. Okay, now this is t to power 9 by 2, it becomes t to power 11 by 2 upon 11 by 2 minus 2 t to power 7 by 2, 5 by 2 plus 1, 7 by 2 upon 7 by 2, and plus t divided by 2, it becomes 3 by 2 upon 3 by 2. More simplification, 2 upon 11, and limit is also applicable here from 0 to 1. 2 upon 11 t to the power 11 by 2 minus 4 upon 7 t to the power 7 by 2 plus 2 by 3 t to the power 3 by 2, and from 0 to 1. Applying the limit, upper limit 1, lower limit 0, so lower limit totally will be fully 0. So this is 2 upon 11 minus 4 upon 7 plus 2 by 3. Okay. Finally, when you will calculate, this is 64 upon 231. This is your final answer. So these cases are the substitution case. One more interesting and important question I am for conclusion. Question number 4, 0 to 2 x plus 2 under root dx. The problem is that now this x plus 2 binomial part is under square root. That is a technically calculation problem. So here we will suppose x plus 2 as a root. Let x plus 2 is equal to t. So this become dx to dt. Basically here is no basic change. And for limit when x equal to 0, then t will be 2, and x equal to 2, t will be 4. Accordingly, you can see here, and we are putting x equal to 0, t is equal to 2, x equal to 2, and t become 4. Now change here, 2 to 4, x plus 2 is equal to t, so x equal to t minus 2, and x plus 2 under root, that is t under t and dt. One more change, this is power 1 and half power, so t to power 3 by 2 minus 2 t to power 1 by 2 dt. Now apply the integration here, so t to power it become t to power 5 by 2 upon 5 by 2, we can write 2 by 5 minus. It becomes t to power 3 by 2, 2 by 3, 3 by 2, it becomes 2 by 3, finally 4 by 3. And now this is limit 2 to 4. Applying the limit 2 to power 5, 2 upon 5, 4 to power 5 by 2 minus 4 upon 3, 4 to power 3 by 2. This is the first part, upper limit, and then minus lower limit 2 by 5, 2 to power 5 by 2 minus 4 upon 3, 2 to power 3 by 2. Okay. Further more calculation. This become 2 square, so 2 to the power 5. Okay. 32. This becomes 32, 64. 32 into 2, 64 by 5. So I am writing value as 64 upon 5 minus 8 root 2 upon 5 minus 32 upon 3 plus 8 root 2 upon 3. It's come after the calculation. Okay. For further calculation, 32 upon 15 plus 16 root 2 upon 15. Finally, you can write as 16 root 2 15 root 2 minus 1. This is the final answer. So students, you can see here, this is the definite integral part 1. It was the definite integral part 1. In next class, we will take the definite integral with property of definite integrals. Okay, that is would be exercise 7.11. Okay, that's all. Thank you.